to get started. Yes, Pawan, you can go ahead.
Hi all. Regarding Redshift, we'll start with a brief introduction of Redshift. What is Redshift? And then we'll go through the basic setup needed to work on this, a training session. And then we'll go through different ways, like what are the different ways to connect to Redshift. Yeah, let's start with the introduction. Let me share the screen. You guys see my screen? Hello?
Yes, we can see the screen.
Yeah, basically Redshift is like a data warehousing product. I will not go through each and every line. I will just highlight the main things which we need to know about Redshift. First thing is it is a fully managed cloud data warehouse. What does fully managed means? We'll see in the next slide. The important thing we need to note here is it supports directly. Redshift supports only structured and semi-structured data. It doesn't directly support unstructured data like raw data like videos, and it doesn't directly support that, but we can host that data on S3, and Redshift provides a way to query that data. But on Redshift directly you cannot host unstructured data. It does only support structured and semi-structured data. This is the point to note here. And fully managed, as I said, like Redshift is fully managed. By fully managed, it takes care of the infrastructure, like all the software, hardware, upgrading the software, scaling up, scaling down, and maintenance tasks, all the software patches, everything is taken care by the Amazon. And monitoring, what is the way to optimize your queries, how long each query is running, all those things, and scalability and fault tolerance, high availability, and all these are taken care by the Amazon. We need not worry about all these stuffs. We can just use it as a data warehousing product where all these things are taken care of. Yes. Key features, if you observe, these are mostly similar to other products which you have explored, like Snowflake and other stuff. Massively parallel processing, and it also stores data in columnar storage. I think we have seen this in other products as well. And it provides us the integration with the data lakes. As I told you, with the Redshift Spectrum, we can query and analyze data stored in S3. Basically here, it means the unstructured data, raw data. We need not move the data into like Redshift. We can query the data directly, which is hosted on S3. Scalability and cost effectiveness. These are, I think, regular things. Yeah, benefits of Amazon Redshift. We have the flexibility because, because of its tight integration with the other AWS things like Glue, Lambda, and other services. That's a additional benefit for Redshift. Tight coupling with these products, that's an additional benefit for Redshift. And serverless architecture, fully managed, so we need not to take care of any maintenance or upgrading stuff. Ease of use. One more thing here is like the Redshift is based on a relational database model because it just supports only semi-structured and structured data. It is based on the relational database model. So most of the people who are familiar with the SQL and all, for them it will be much easier to work with Redshift. So security, it's a built-in thing. It offers encryption for the data at rest and in transit, and support role-based access control. Yeah, generally what why Redshift is used is like for data warehousing, business intelligence, machine learning, and real-time analytics. These are all regular stuff where most of the products like are used for this stuff. The main things we need to remember here is first it supports semi-structured and structured data. We cannot host unstructured data on Redshift, but it allows us to query the unstructured data which is hosted on S3. Yeah, that's a brief introduction about Redshift. Uh, to do this, use case, to run this use case, we need to do some setup on AWS. I will give you the steps, like what to do and all. But before that, I want to go through a couple of things which are needed. For people who already have done like this AWS certification and all, I think they might be aware of all these concepts. But for people who are new to AWS, I'm just going through a couple of things here. Like any system, in any system, if you want to give a user permission, we create some roles or something permissions, and we assign the permissions to the user. But in AWS world, it is mostly similar, but a small difference is there. In AWS world also, we create a role, what we call as a role. This tells like what are the permissions that a particular user has. Okay, we can assign the permissions in this role, in the definition of the role, and we can assign the role to a person. And person, when the person logs in, he will have all those permissions. That is similar to any other system. But the key difference here is, in addition to people who are physically logging in addition to people, you can assign this role to services also, AWS services also. For example, if AWS Redshift is a service, AWS S3 is a service. For example, AWS Redshift wants to interact with AWS S3. You can tell that, okay, let the AWS service Redshift, let the AWS Redshift, the Redshift service take this role and let it interact with S3 as if a real user is interacting with S3. You got the point, right? We can create a role which has all the permissions. This role can be assigned to normal users or it can be assigned to AWS services. Assigned to means we tell the system, okay, these are the services which can assume this role or which can take this role and act like a normal physical person. See here, the key components are two things here for the role, IAM role. First thing is permissions policy. Permission policy tells like what are the things person having that role can do. Like this defines what actions the role can perform on which resources. Example, to access S3 bucket on a Redshift cluster or a Redshift cluster. This part tells like what that role can do. Okay, the second part, trust policy. This part tells who all can have that role or who all can assume that role. It can be user, it can be a service, or it can be account. Any of these can have or any of these can assume the role which we create. The first part, I think the permissions part, role and permissions part, you will see in pretty much every system. Role based access where we control security using roles. This part is similar to most of the systems, but the second part here, the difference is users, along with users, in addition to users, services or accounts can also assume this role and they can work as if they have permissions like a normal user. That's a key thing to note here. Are we good with this? Or do you have any questions? Hello?
Yeah, Pawan. I think we are good.
Yeah. Okay.
No, it's
Uh,
live.
sorry.
a bit complicated right now to go through all of it, but yeah, I think they're digesting the information. You can go ahead.
Okay. So how to set up this Redshift? Like if you go to AWS console, let me go to AWS console here. Sorry about that. So if you go to AWS console and click on AWS Amazon Redshift, it will take you through steps. Like, I have configured already all these things, but it will take you through steps which are straightforward. You can just click on default settings, give some names for the resources you want to create, and then it will let you create these things, namespace and work group. I will tell you like what are those. Just give me a minute. Here is a link. Mm, I will share you this link with you, the getting started guide. Once you click on that, sign up for AWS, and once you click on the Redshift serverless, it will, this is how it looks. Get started with Amazon Redshift serverless. You can click on use default settings and then give name for your namespace and give name for your work group. It will just ask few names and default settings. You will be able to create a work group and space. What is a namespace and what is a work group? We'll go through it. But before that, one more key point here you need to observe is this Amazon Redshift serverless. Like when you set up this, it is not hosted on a server which is publicly available. It is hosted in a VPC, virtual private cloud. See here, Redshift serverless requires an Amazon VPC. That means our Amazon Redshift is hosted within a VPC. Just remember this point. Why I'm touching on this point, you'll come to know, you'll come to understand later. Just remember that it is not hosted like any other server which is publicly available. It is hosted within a Amazon VPC. This is we don't do all this. This is all by default. It will take care of all this. Just, but we need to remember this, because while configuring the test case, like we need you need to understand like this point. Okay. Yeah, and the keywords here which we need to understand is namespace. What is a namespace and what is a work group? Namespace is nothing but a collection of database objects, users, like schemas, tables, users, snapshots, all that stuff. We group them and we call it namespace in Redshift language. And work group is nothing but like a cluster, basically a collection of compute resources. Workgroups house compute resources that Redshift serverless uses to run computational tasks. These two basic definitions, like namespace is a collection of database objects and users, and workgroup is nothing but a collection of computational resources, just like a cluster or compute resources in a database, similar to that. Okay. So now, yeah, when you go to the console and click on Amazon Redshift serverless for the first time, it will directly take you to this configuration. By selecting this use default settings and clicking on continue for a couple of screens, you will be ending up creating a namespace and a work group. Just we need to go through the default settings. No need to change anything. Just click continue, and then you will be ending up here. You will be ending up with a default namespace and you will be ending up with a default work group. As we seen, namespace is nothing but a collection of database objects and users. Workgroup is nothing but a collection of computation resources, computing resources. Okay. And on this page, they have also like given, if you want to explore, they have also given like what are the different ways to load data. Here they are exploring the way to load sample data. So Redshift also gives us some sample data to play with. Here they are just going through how to like load that sample data into our Redshift serverless database and all. You can go through. This is all self-explanatory. Yeah. Now if we go to the bottom, I want you to show like different ways of loading data into Redshift. So there are different ways to load data into Redshift serverless. First thing is we can copy all your put all our data or write all our data to an Amazon S3 bucket, and from there we can copy that into Redshift serverless. Okay. The second way is if you have a local file which is smaller than 5 MB on the server directly, you can directly read from that file and load into the database. The other ways to connect is Redshift serverless also provides JDBC and ODBC based connections, driver based connections. So you can connect using JDBC or ODBC. Also, they provide a data API. Using this data API, also programmatically you can connect. These are different ways, like how you can connect to the Redshift serverless and how you can write data to it. Today we'll be focusing on the first thing, like how to write data from S3 bucket. Like first we'll from Databricks we'll write data to S3 bucket, and from there from S3 bucket we'll load that data into Redshift serverless. This is the use case which we will be covering today. Now coming back to the setup, we need to do some setup to execute the use case. Basically nothing much, simple. I will just give you a high level overview. The first thing we'll be doing in the setup is creating a role. Basically creating a role means like giving the permissions needed for the Redshift serverless service to act or to connect with S3. Okay, for that purpose we are creating a simple role. So how to create a role? If you are new to AWS, again you can go here. Sorry, so in the services, if you click on IAM here, IAM means identity and access management. Here you have roles. So if you go here, you can create a new role. For example, let me show you the role which I created. This is the test role which I have created for our training purpose. So if you see here, the main two parts to it. First thing is the permissions, like what are all permissions this role can give you. Okay, the role name is blue ETL role, and these are all the permissions like given to that role. Okay, this is the first part, and the second part here is relationship or trust policy. What I'm telling the system here is, okay, all these services listed here like Glue, ECS, data pipeline, logs, events, all these services which are listed here, all these services can assume this role. Means they can, all these services can take this role as if they are like physical persons. They can take this role and they can have the permissions which come with this role. These are the two parts. Don't worry about all these permissions and all. It's all documented. We'll share the document like what are the permissions needed and what are the things we need to mention in the trust relationships. All those things we have documented. And here also the access we have given is actually more like, I mean, to just execute the Redshift use case, we don't need all this access. These are all extra access. Just for training purposes, we created this role, so it will have more permissions. So while playing around, be clear, like change the role or delete all this stuff. Basically, this role gives you more access than required to execute this case. That's what I wanted to tell. So first thing is creating this role. See here, I have given in the steps. First thing is creating a role, sample role, like, and then clicking on the edit trust policy and mentioning all these services. These are the services which can assume that role, and this is how it looks like once you create the role on the trust relationship. Once the role is set up, then we can go to AWS Redshift from the console as I shown earlier. When you click on the AWS server Redshift, It will take you through basic setup, and using that basic setup, I have created a namespace and a work group. The namespace, my namespace is test namespace, and the date, and my work group name is test group and name. And similarly, you can create a namespace and work group. Simple setup. Just click on next and give names, whatever names you want to. And once we created the namespace and work group, the next step would be to tell or associate the role which we created. Like this is the role, right, which we created. We need to associate this role with the namespace. So click on namespace. Once you have created a namespace here, click on the namespace and then go to this tab, security and encryption tab, and tell that this particular namespace, tie up this particular namespace with this role. That's all we are doing here. Okay, and then I have mentioned earlier, like Redshift serverless is hosted on a VPC, on a virtual private cloud. So to give access to Redshift, to give outside world access to our Redshift server or database, we need to do two things. First thing is, on the server or namespace level, we need to say that it is publicly accessible. This need not be the case always. Here, if I say publicly accessible, what I'm doing here is I am letting anyone in the world to connect. But that will not be a real world scenario. In real world, you will be giving access to a limited set of IPs or a limited set of networks. So this is just for training purpose. So first thing we are doing is, like, we are turning on publicly accessible, means we are saying this Redshift server is open for anyone to access. This is on the Redshift server level. But as Redshift server is hosted on a VPC, we need to do one more round of configuration on the VPC level. It's like VPC, Redshift is hosted inside of VPC. So we are saying Redshift is open, but if the VPC is closed to the outside world, then people cannot, or system programs cannot directly connect to Redshift. So we need to allow the outer gate, which is VPC. We need to allow the outer gate also, like we need to let that open. So we need to do some configuration on the VPC also. Think of VPC like a outer gate to your house, or like compound wall to your house or to the Redshift. So first thing we are doing is we are setting the Redshift publicly accessible, turning on by checking this box, turn on the publicly accessible setting. Here we are saying that Redshift will be publicly accessible. And then one more step is there, which I will show you. Yeah, here. Once we are done with that, we can go to the VPC. VPC, again, you can access VPC from the Amazon console, which is, yeah. You go here, you can see VPC here. If you click on VPC, it will take you to the VPC, default VPC on which your Redshift is hosted. When you create a Redshift, you don't configure all this stuff. It will, by default, it will have a VPC, and by default, it will host your Redshift server on the VPC. So when you click on the VPC, it will directly take you to the VPC on which your Redshift is hosted. Within the VPC, we'll be doing some configuration. Basically, nothing much. We are just allowing traffic, outside world traffic, through VPC. So you go to the VPC, go to the security endpoints, and then security groups, and then here you add this thing, inbound roles. Go to the inbound roles and you say allow Redshift traffic, and the IP range here, basically this means you are allowing any IP address. So it's like opening the outer gate. We are opening the outer gate here, and the inner gate is nothing but the turn on publicly accessible setting on your Redshift. we have two gates here. Once we open this, anybody can access or anybody can connect to our Redshift server. So these all are documented. Need not worry about this. Just follow this. You will be able to replicate. And similarly on the VPC, we will be editing outbound rules also. Same thing. We are saying Redshift can be connected through all these IP addresses. So we have two gates. We opened both the gates and we created a default namespace and our group. All this is simple thing. Yeah. Once you are done with this setup, once you are done with creating the Redshift server, then you have this option, query data. Let me show that here. Let me go back to Amazon Redshift. So here you can see, right? This is how it looks. Once you configure a namespace and workgroup, this is how it looks. You have the option to click on query data. Once you click on query data, it takes you to a basically editor, a query editor. And here you can see what is your work group name, cluster name basically, and what are the databases within it. This is the default database that it comes with, and what is the schema name. This is the default schema name that it comes with, and what are the tables inside, views, functions, everything, all this here. So to connect to the Redshift here, once you click on this query editor and once you select table name or any database name, then it will take you to this screen. Before connecting, you need to create a user. This is how it looks initially. Okay. When you click on the serverless, basically when you click on the work group name, it will ask you for credentials like what username and password. Now there are three ways to connect to the Redshift server. Basically, this federator user is what you select initially. Federator user means it's like a one-time temporary password. It generates automatically. We need not do anything. If you just select this federator user and click on create connection, it will connect to the system and it will take you to the query editor, and you will be ready to run your queries. First time you connect through this federator user, and then once you are connected to the query editor, there you can create a username and a password for your database. Okay. You create a username and password which can be later used to connect to the Redshift from outside, like you through a program. Basically, when we connect to the Redshift from a Databricks program, we use this username and password. That's what I have done here. Is that query editor? Yeah. If you see here, I created a user already. Create user, simple thing. Create user, the username and the password. Okay. And then I have created a table named user table just for training purposes. This is my table name, and it's a simple table with two columns, name and age. Okay. And once I have created the user, uh, I just gave all the permissions, like granted all the permissions on the table, particular table, user table, to this user. These are the basic things which you can do. First time you need to connect it using the option of federated user. Once you connect, you can create a username and password through which you can connect later, and you can create a table and do all this stuff. Okay. I created a table, and currently my table has, I think, two rows. Oh, it has three rows. My table has three rows. So this is the table which I created, and this is a like a normal query editor. If you are looking at it, just like any SQL editor, you can write queries, execute, and you can see the historical queries which you ran earlier. History is stored here. There are options to schedule, charts. Notebooks is again like similar to, haven't, just store the code like SQLs or anything. Create folders and store the queries inside, and the queries here. Yeah, so this is the basic setup that is needed to access Redshift server. So once you connect through the federator user, remember to create a username and password with a password, and create a training table and grant the privileges. So this is all the basic setup which we need to run this use case. Once all this is done, our Redshift server is ready. So we can go through Databricks. Using Databricks, what we are doing here is, first we are writing our data through a S3 bucket. From there, from S3 bucket, we are copying the data to Redshift table, our Redshift table, which we have created. Remember, our Redshift table has already 3 rows, so we'll just modify the data. I will say a. Okay. Hmm. So first part is pretty straightforward. I think we have done similar things earlier. We are connecting a S3 client, basically a client to connect to Amazon S3. For that, we are providing the access key details, and client name is S3. We are using a module called Boto3. Using the module, we are creating a client. This is all, I think we have covered this in earlier sessions also. So I think most of you might be aware of this already. And once we create a S3 client, then we create a Spark session, and then we are creating a data frame. This is all normal Python code. We are giving 2 columns, name and age, and creating a data frame. This is the data sample data, 3 rows of data, which I am putting in the data frame. And then I am saying that I want to, first time what I'm doing is, first I'm writing all these 3 rows of data to a file named, let me give my data comma 10 April, something like that. My data comma 10 April CSV. First I am writing to this file on S3 bucket. Okay. So S3 client, we have created the S3 client earlier, S3 client dot upload file. And we are giving the path. This is the path where we want our file to be loaded to. And I think this is all. And then, yeah, this part is to connect to S3 and write the data to S3 bucket. And now comes the Redshift part. For Redshift, we need to give all these details: Redshift cluster URL, database name, username, password, and the table which you are accessing. From where we can get this data? We can get this data from here, from the, once you create the default namespace and work group, once you click on the work group name, you can see all those details here. This is the endpoint URL for your Redshift cluster. So we need all this data. What is the URL? What is the port number? And what is the, this is nothing but the database, default database dev. And as I told earlier, we have other ways to connect to Redshift as well. That is through JDBC and ODBC drivers. If you need to connect through JDBC or ODBC drivers, you can find the JDBC URL and ODBC URL here. You can copy this and you can use this information to write data through JDBC or ODBC drivers. So this is the stuff basically I copied here. This is our endpoint URL to our Redshift server. And this is the port number. This is the database name, which I copied. I have given that my database, cluster URL name, database name. Remember user and password we created on the query editor. I have given the same username, password name, and I have given the table name, my table name. Public here is nothing but the schema name. Within this database, public is the schema name and the user table is nothing but my table name. I have provided all those details and I am using a what is that? Yeah, I'm using module called PSYCOPG2. Using this module, I am creating a connection to Redshift cluster. Okay. Once this is done, I am basically creating a query and I am executing that query using our connection. So first thing is creating a connection, and using that connection, I am creating a cursor, and using that cursor, I am executing my query. Look at this query. This query, what this query is doing here, it is basically copying data from our Redshift table bucket name. This is the path from this, and it is using the IAM role. You need this role. This role is nothing but the role which we created, glue ETL role here. You can copy all this from the role details. Let me show you from where you can copy this. So if you go to IAM, roles, here you have all this information, ARN. This is what I have copied there and I have pasted there. Okay, I am saying CSV, ignore header, first row. This is all the copy. This is the copy command. Basically, I am copying data from S3 bucket to our Redshift table. So here the file name should be this thing. So first we are creating a connection and then we are creating a cursor, and using that cursor we are executing this copy command. Once this is done, I think the data from S3 should be loaded to Redshift table. We'll see that. So I'm going to S3. This is my bucket name. As you see, a new file got created here, my data underscore 10th April. And let's see if the data got copied into our table or not. Yeah, as you can see, 3 rows which we have written are now copied from our S3 file to Redshift table. So main things here to remember is basically Redshift setup is pretty straightforward. You simply need to go to the Amazon Redshift serverless. It will walk you through the steps, basic steps that are needed. Not much complex there. Before that, we need to just create a role. What are the permissions needed? What are the trust policy needed? All those details we'll share with you. Just we can copy paste that and create the role. First thing is to create a role and then set up the Redshift server. Once you set up the Redshift server, we need to do two things. First thing, on the namespace level, we need to open the gates for the external world. How we do that? We simply check on the turn publicly accessible checkbox there and save. And once the inner gate is open, we need to open the outer gate as well, which is nothing but our VPC. Go to the VPC settings, just follow through the document and uh, open it to the IP addresses which you want to allow the connections through. So just do those two stuff, and then when you connect to the Redshift server for the first time, you just connect using the federator user. That is the default option. Just you select that option and connect for the first time. Once you connect, you can create a username and password, and you can create tables and give access to that tables. That is like pretty much like a normal database, SQL database. This is all the setup we needed, and once that is done, it's straightforward. Like we are connecting. First, we are connecting to the S3 client. We are writing a data CSV file to the S3 bucket, and from there, we are copying. How we are copying? We are creating a connection to the Redshift cluster URL. These things we can copy from the work work group. When you click on the work group settings in the AWS Redshift, you can see the URL. You can get this URL from there. You can get the database name, username, password. You will be creating this, and the table name. You will be creating this. So you can give all these details and you can create a connection. Once you create a connection, we need to create a cursor object, and once you create a cursor, you can execute the query. Basically, we are preparing a query here, and this query gets executed on the Redshift. So here, see here, this query doesn't just have what to do. It is also telling Redshift that Redshift can use this role. Redshift service can use this role. This role, Glue ETL role, which we created initially, this has permissions to access S3 and all, which I showed you earlier in the document. Here, if you see here, Amazon S3 full access. That role has full access to S3. That is why Redshift service, just like normal user, is able to copy connected to the S3, and it is able to copy the data from S3. So that's all about the use case. Any questions?
No questions. I'm pretty sure it's a bit overwhelming.
Oh, okay.
Yeah, normally we kind of provide the instructions, right? But you have gone through each of the points very well in detail. So that is very good. I mean, when they go back and refer the video, they can follow step by step very easily. So that's very good instead of just giving instructions like you do. So that's very detailed. But I'm sure, like, at this point of time, it's kind of, I think it's a lot of information to digest at least, but it's very detailed. Thanks, Paul. That's what I appreciate it. What do you guys think, Nabi, Ramya, Anirudh? Hello? Hello, am I
Everyone is
audible?
on. Yeah, you are audible, Arun. Yeah.
Okay, okay.
Yeah, yes, sir, and you're audible. Yeah, thank you, Pawan, for the insights.
Yeah. All right. I think, I'm not sure, Nabi or Ramya, just there. You're on mute if you're talking. Maybe they're talking on mute.
Thanks for the presentation, Pawan. Yeah, it was so good.
Yep. All right. Okay, thanks, Pawan. Thank you so much. Appreciate it. So 1 second, let me just pause the recording for a bit and then